dealing with campfire impacts, hatchet impacts, incision, truncation of vegetation, eradication of vegetation with social trail formation, we have some things that work pretty okay. The difficulty here is that we are doing intensive localized management, fixing, removing, renaturalizing, making less appealing a social trail in a very large place, in a very busy and very large place. And that is a lot to try to keep up with. So these techniques work really well. It's just sometimes your millions of visitors can kind of outpace what you can keep up with as the trail crew or the restoration ecology team or something like that. Okay? So ask yourself, are we running trails over vegetation like grasses that can lay prostrate and spring back up like group campgrounds where we stayed at Land Between the Lakes last summer for summer camp has a place, several places that can handle literally thousands and thousands of tents. They're just big, open, very flat, so there's not a lot of erosion energy, grassy fields that they just keep mowed with vigorously growing grass species, and people throw down tents. They're gone after several days, and it's been like that for years and years and years, and no measurable impacts, right? So, can you work with certain patches of veg that can work with you? Can you, where that veg isn't available, and where we maybe don't have areas of exposed bedrock, also very durable and resistant to impacts, can we characterize those impacts so we can track them over time, figure out where's growing the fastest or worst, and be able to respond and put together a strategy that is well-reasoned instead of just a knee-jerk reaction. Oh, we got to shut this down. Sometimes just shutting down a trail, putting a fence across it, has people go back out, if there's something interesting at the far end of that trail, on the left side of the fence and around the right side of the fence. And now we have 3 informal trails where we had 1 specifically because we tried to fix the problem and didn't think it all the way through. So typically you are finding campsites, and in terms of finding campsites that people have created on their own, like in a wilderness area or the back country or primitive or wildernessy sections of a busy national park. These are not designated campsites. These are not hardened. They're not sited with an eye towards sustainability and resource integrity and function. They are just a cool spot for a tent that tends to be fragile and it starts to open up and grow on its own. Okay, so record the perimeter with a GPS app, or use photogrammetry, or use the variable or fixed radial transect method to get a sense of the size and shape on the map of this campsite. Obviously, the high-tech, easy solution is to fly a drone or pay somebody every 5 years to overfly with a surveying plane or something like that, but that doesn't work in heavy canopy. Color LiDAR can help detect campsites under heavy canopy, but it is difficult and specialized work. So that's not really a thing yet. If you have a wilderness area the size of Wrangell St. Elias up in Alaska, you might have 5 to 10 million acres of wilderness to try to figure out where this stuff is. Try to figure out where people are sort of burning campsites or trampling campsites into the surface of the planet. And that's a big effort. And it would take a whole lot of GPS battery that you are hiking in or bush plane or float planing in on your own. So we got to use non-GPS methods like the variable radial transect or fixed radial transect in those cases. So fixed radial transect is just a survey technique. We'll go through that in a lab session later on the semester. And it's a pretty quick and easy thing. You just got to record some numbers, then you dump them into a spreadsheet. Later on, you don't have to do any computation yourself. It's just triangle math and stuff like that. For species composition change, as veg is not completely gone yet, but is heading that way or trending that way with trampling or disturbance pressure. We want to collect stuff like cover change in terms of how many pixels, if you had an aerial photograph, used to be green but now they're brown. Would be one way to think about it. We got relative change, and then multiplied by the actual area of loss. The intensity of the loss by the area of the loss gives you absolute change. And as you can see, this is just addition, subtraction, division, multiplication. Very, very simple math, right? So what's the off-site veg cover versus the on-site percent veg cover, and what's the difference between them? Divide that by the off-site percentage cover, multiply by 100%, and you get the relative change. Pretty simple stuff. Veg height reduction, you're setting a line, a transect line, and then measuring from the point on that transect line that is immediately over the deepest part of the incision. So if I got a line of low bush blueberries across here and people have been walking through them and creating a visible social trail through there to get to more berries further in, or just to get to maybe an oceanside cliff vista or something like that, sitting on the far side of this bank of blueberry, we would set a rigid tape across the top and then measure an incision, a depth, down into the lowest point of that incision. And that gives you the veg height reduction. It's a fairly simple number, and it's also a fairly dynamic number. So this is one of the ones that we're not measuring every 5 years. This is something we're going to try and capture after each season. For every one of these measurements, we're always trying to think of how often am I repeating this to track the life cycle of this damaged campsite or blown out trail, something like that. The other way to get after species change, floristic dissimilarity, is just an index. It'd be like a slightly elaborated version of, like, Shannon wine or something like that. Again, it's very simple math, but for those of you who really hate math or are dysgraphic, the symbol here is a summation across all measurements. So we are getting relative cover of species off-site minus the control. That's a difference. It's P1. And then we subtract from that the relative cover of species on-site, P2. And then we take the absolute value of that difference of differences, and then we sum all of those, or sum those, and multiply by 0.5. So that sort of weird sigma character means summation across the absolute value of. Vertical bars are the absolute value. Okay. You also want to think about planting stuff. We're totally allowed to do that. This is prohibitively expensive and difficult in a huge national park, which might be millions of acres, but we get the ability to vegetate areas with trample-resistant grasses. We can not really plant mosses per se, maybe with some intensive restoration ecology work, but forbs and mosses, we're mostly going to route stuff away from this. We're not planting, we are moving the human presence away. Fruticose lichen grows up and away from, or foliates up off of, as it desiccates, off of the boulder or rock surfaces, bedrock. It is very, very fragile. If you touch it, it can crumble to powder. Just kind of rubbing it between your fingers. Crustose lichen is extremely durable to impact. It's just this thin sort of dry slime that grows in these little circular patches on top of boulders and cliff faces and stuff like that. And you're going to walk over it quite a bit, up to a point. So you can route where you're not too worried about generating soil along bedrock faces. Route stuff right over crustose lichen, but route it away from fruticose lichen. Don't let people even see this stuff. It is that fragile. All right, so here's an example of one study we did in Washington, D.C. at C&O Canal National Historic Park. The Potomac River runs through there, and this is the just copy-pasted field data sheet that we used for capturing impacts to the cliff vegetation, things that were growing in little cracks and pockets that climbers sometimes want to clean out with bleach or a wire brush to develop extra handholds for developing a climb. We got on harness, rappelled down the cliff face, and put quadrats not horizontally on the ground but vertically. If you think of a trail as a climb route as a vertical kind of trail, you can measure impacts in exactly the same way. So this is vegetation loss. It is getting other disturbances like sport bolts drilled into the rock. That is a permanent modification of a public natural resource, super duper illegal, and so forth and so on in some places. It's actually okay here, but we want to understand what's the underlying geology, because that's going to drive what kinds of lichens and other plants can grow in the little cracks in that particular mineral type, and so forth. Okay? So, it's a couple of boring math formulas, but this is the actual production stuff. Like, this was a project of the United States National Park Service and the Nature Conservancy, which co-manage this particular area at this particular National Historic Park. Okay? So, yeah, it's just a couple of boring formulas, but the data represented by those formulas are exactly what the trail boss, the chief of resources, the staff ecologists need, the botanists need to understand what exactly to do at each one of these, in this case, climbing sites. The exact same conversation is held in the Shawnee National Forest headquarters at team meetings, because we have a bunch of climbing sites at places like Jackson Falls Natural Area where people are, in some cases, cleaning from climbing routes that they are trying to develop. Ancestral, isolated or marooned glacial vegetation communities that live in these pockets in vegetation, 10,000 years after the last glacier retreated back up into Canada. Some of the central Canada biological communities exist only in these cracks and crevices along the Shawnee Bluff lines, and those bluff lines also happen to be awesome climbing in certain areas. So this is a real thing, right? Recreationists with understandable motivations trying to develop climbing routes, leading to the need for forest or park field staff to measure this stuff, to figure out exactly what's going on, exactly where and exactly how, taking those measurements we just went through, and then figuring out what to do from there. Do we close down the area? Do we work with the climbers? Do we arrest them and slap them with fines and stuff like that? Like, how kinetic do we want this situation to be, or what are we trying to keep it from devolving into? Okay, cool. Let's pause it right there, and there's so much more good stuff. We'll get to it next time. Let's head outside, and we'll go out in front of the ag building here and check out some tree climbing.